What I want to do right now is be sure we have a shared understanding of one thing. The thing that I want to share, and I'm going to spend the next few minutes on, is why bioregional scale? Why do we have to work at this seemingly impossible scale if we can't even fix our damn sidewalks, right? Like, we have these piecemeal problems we can't solve for the very reason that Susan said. Problem-solution mindsets don't work. We have to live into the whole system. And that's what I want to spend just a couple minutes. This is going to be the whirlwind tour. And it starts where I think we should always start, which is to look at our mother. To look at our mother and notice that you can't cut her into portions. You can't divvy out little pieces of her separate from the rest of her. That if you cut her to pieces, she dies because she is wholly and completely integrated. There is not a single boundary in this image. Even if you look at the dark edges of the earth, if you looked in the infrared, you would see the magnetosphere. You would start to see that it doesn't even have a boundary there. And if I was to ask you on this image of the earth, is there any place in that image that does not have water? No, because there's water in the oceans, in the clouds, and vapor moving in the air, continually circulating and bringing life to a living planet. And that interdependent web creates two things: deeply interdependent resilience and profoundly interdependent systemic risk. And by understanding this double-edged awareness of risk, resilience, and interdependence, we see the path forward. When we ask ourselves, what is the state of the world today? And I think many of you have seen me talk about this. One way to answer what's going on with the world today is to take an Earth systems lens and say there are these different systems of the Earth. The tectonic plates move around, the oceans circulate and mix things, and there's all kinds of Earth systems processes. And when a group of about 3,500 Earth system scientists came together, and they asked, are there any boundaries that if we crossed those boundaries, we would leave the warm, stable period called the Holocene? And our idea of stable population centers, of civilizations, of things that depend on that stability, that those things would just go into question or go away. They asked that question and they come up with the answer that there are 9 critical thresholds. By the way, the thresholds could change if one of them is connected to another, way more complex picture. But there are these 9 thresholds that if you crossed even one, the idea of civilization becomes a question mark into the future. And the more of them you cross, the more questionable it becomes. And so I'm just going to run through them real quick. We all know climate change. Everyone loves to reduce the entire planet to the amount of carbon dioxide molecules to ignore all the rest. So climate change is only one of the 9. Biosphere integrity, which is the rate of extinction for our beautiful mass extinction event that we're in right now. It's a lovely thing to watch. Land system change, the primary cause of that extinction, which is to take healthy, intact ecosystems and degrade them and turn them into parking lots, urban landscapes, monoculture crops, and deserts. Freshwater use, because only 1% of the world's water is freshwater, and 99% of that freshwater is dammed and being contaminated in lakes, let alone the groundwater, which is its own whole thing. Biogeochemical flows, which is just a fancy way of saying industrial agriculture uses fertilizer. And fertilizer spreads a whole bunch of reactive nitrogen, which causes our rivers and our oceans to die. They actually call them dead zones, and they're at the mouths of all the major rivers of the earth. Ocean acidification, have too much acidity, all of our calcium carbonate goes away, it dissolves, no more coral reefs, no more complex biodiverse life in the world's oceans. Atmospheric aerosol loading, in other words, pollution. Stratospheric ozone depletion, that protective boundary for ultraviolet radiation that would kill all life on the continents if we didn't have the ozone layer. And then novel entities, ingenious humans creating stupid things that the planet can't handle. So we got 9, and they asked the question, this is like 2013, they were like, so how we doing? Did we cross any? Oh, crap. We crossed 4. That's what they said by 2015 when the peer review research came out. That doesn't mean we crossed them in 2015. That's just when they asked the question and got their answer. In 2015, oh, we crossed 4 of them. But then they keep doing research. A couple years later, oh, we've crossed a few more. Oh, wait, there are these things called microplastics that are in the breast milk of every mother on earth. Maybe those things shouldn't be there. And you see, we've got to picture something like this. What this tells us is that the future is not going to be like the past. That if we keep thinking with the way we thought before, we're only going to get more of this until we are not part of this story anymore. And with this kind of a complex reality of where we are today, we're not going to solve this by changing light bulbs or taking a single occupancy vehicle with an internal combustion engine and replacing it with a single occupancy vehicle that requires us to scrape the ocean floor to get lithium. It's like we have these stupid problem solution ideas. To address this, we have to do what Susan said, which is change the story. And so to change the story, we need to understand what's causing this story. What most people don't know is those planetary boundaries are explained by the tipping points of the Earth system. That the reason those boundaries exist is because when you cross one of those boundaries, you are crossing some of these. I'm going to name a couple. The Amazon rainforest shut down its hydrological pump this year and is in the midst of collapse. Woohoo! I wrote about that in 2020, saying it would happen in 2024, and sadly I was right. The Amazon rainforest is collapsing right now. The boreal forest is on fire every year. The Atlantic circulation is shutting down, it's slowing down, it's 15% less than it was in 1980 because the Greenland ice sheet is gushing fresh water so quickly. And oh wait, the West Antarctic ice sheet has little chips breaking off of it. And you start to see, by the way, the permafrost is exploding methane into the atmosphere as the permafrost melts in Siberia. This is not a story of the future. This is a story of systemic interdependence. But here's the secret. If you look at this picture as I'm scared as hell, what is going to happen, you freeze. But if you stop and notice something profound, this picture required millions of human hours of labor to gather the data and the research and the knowledge to tell us how the Earth works. Which means you could use this same knowledge to reconnect the pieces, to restore the stability of Earth system processes, to regenerate the whole damn planet. Everything, everywhere, all at once. That's it. We've got to restore these linkages through healthy relationships across landscape systems across the planet, and the scale of our intervention is bioregions. So, the lesson is this: the Earth is a whole system with cascading consequences, positive and negative. Negative consequences are things like too much CO2, too much warming, too much Greenland ice sheet, shut down the mixing of the Earth's ocean. Right, that's cascading negative consequences. Cascading positive consequences is restore our regional small water cycle with forests and integration and healthy rivers, and do it over here too. And oh my gosh, the jet stream actually connects them to each other. You see the picture now? It's actually possible to regenerate the whole frickin' planet if we think about the whole frickin' planet. But not if we think about carbon dioxide molecules or changing light bulbs or some other reductionistic nonsense. What's amazing about this is because the breakdown unfolds across space and time, the buildup takes place across space and time, which means it's hard to see this story happening. And so, this is the insight that I observed that shows how to do this, is that I traveled all over the world looking at regenerative projects, permaculture farms, reforestation, all kinds of cool things, and they all happen like the Courtright Center on its 550 acres of land. It's a plot of land. We tend to divide the world into these little pieces. Oh, there's a plot of land, huh? But that plot of land has got ecological connections. Water flows on, water flows off, air moves over, animals migrate across it. Those ecological connections are organized as holistic landscapes, as watersheds, as regional hydrological cycles, as coastal estuaries. These holistic landscapes are our bioregions. It's the whole life scale. And those are embedded with, in, and help to shape planetary processes. Which means What's the scale that you work at? Trick question. All of them at once by focusing on the connections between them. I've got my little plot of land, but my neighbors across the fence have a plot of land. We're ecologically connected. Maybe we should collaborate. Maybe we should organize management around a watershed. And then we could actually get up to the scale of holistic landscapes. And if our landscapes talk to each other, which nature already does, if humans did it too, then we could go, here in Toronto area, we could help regenerate all of the Great Lakes. The Great Lakes are connected to, the Mississippi River Basin, which is connected to the Gulf of Mexico. Oh, damn, those things aren't separated. We get to the planet. And so, just a quick, fly through. Here's Turtle Island, AKA North America. And you're like, that's this big thing. And you're like, all of the moisture of this thing comes from here, right? The Pacific Ocean, dropping snowpack on the Rocky Mountains, bringing the Alberta air down to the Midwest. Oh, as if the Canadian border matters to air. Air doesn't care about that. And when you look at that, like, okay, so here we are, and where we are is organized. It's structured. We're in the largest concentration of fresh water on Earth, a giant basin called the Great Lakes. When we zoom in on those Great Lakes, we're like, that's a lot of cool structure. And we're right there, right? Because the Great Lakes are all connected to each other. Like, that's so interesting. We zoom in more, and like here we are at the court, right in there, in the middle of the GTB. Like, maybe what we're doing right here is powerful because it's not only right here, because it's organized at these large scales. And so, this is I've said this in previous talks, some of you have heard this, but I want to review. Land is organized by its natural organizing patterns. And when you look at the shape of land, you'll see the land has information that is shaped in particular ways. If this was like a watershed, for example, every watershed on Earth has a unique geologic history, has a unique history of the movement of tectonic plates, of the sedimentation and the erosion patterns. They make that place unlike any other place, even if they're universal patterns of creation. And those are connected to the unique kind of life that can live in that place. In this place, you have these beautiful forests, these wonderful moraines, this incredible absurdity of water that you have here. Like, the amount of water is nuts that's happening in Ontario. Your ecological history is unique in this place. It's unlike anywhere else. You go out to Colorado, it's not the same as here, right? You go over to Siberia, not the same as here. And every place, if humans have lived in that place, there's a unique cultural history. When you put these things together, you get this amazing thing, the story of your place. You're already in the story of this place. And by being in the story of this place and constructing this history, you start to see health and flourishing. Oh, this was a place where ecosystems were amazing, and there were fish in all the rivers and the lakes, and humans were here. They used canoes because, damn, if you walk too much, you end up running into water. You might as well have canoes. And they had all these ways that they lived here, right? And you can learn from that to say, I think we have an understanding holistically of how this place works from that history, which gives you the ability to imagine futures that are regenerative and flourishing for this place, but only at the scale of the whole life context, right? The whole life context. When you look at that geologic history, you'll notice that Niagara Escarpment, which most people on Earth, I didn't, I'm from the Midwest, I grew up in Missouri. What's the Niagara Escarpment? You guys here, you should be sure every kid in school knows what that thing is, because that is damn cool. That's why we have the Great Lakes. So, this ability to see the story that you're already a part of is to think bioregionally, to see the geographic range of life for your place. And so, just real quickly, how do you organize around natural patterns? That's Eugene, Oregon. You can see where the degradation is. It's in the watersheds, it's in the river valleys. If I was to ask you, where would you want to restore the health and well-being? It's pretty obvious. It's in the floodplains. They turned forest into agriculture. And you look at this middle one, that's about like 10 miles long, so like 16 kilometers. That's a human scale of organizing. So you can imagine a group of humans, people coming together across these 20 or 30 pieces of land, creating a framework of collaboration and regenerating that valley. But, oh, woohoo, reality is nested in scale. So if you go out to a bigger scale, I've turned it sideways, north is there. This is the Willamette Valley in Western Oregon. And like, how would you regenerate that massive thing that's 160 kilometers north to south? And the answer is the same way. You'd organize these smaller scale landscape features and you just parallel and replicate them around. But then you look at something huge like the Columbia River Basin, big as the Colorado River Basin, about the size of the Great Lakes. It's freaking huge. How would you regenerate that? Oh, well, there's the Willamette Valley. And you start to see these nested levels are about parallel collaboration, about repeating human scale processes of organizing and managing in parallel, nested within and across scales of a system. And then you start to see that you could organize an entire continent this way. And now we're talking about how to really regenerate the earth. And so the lesson here is that landscapes show us how to organize ourselves. We organize ourselves into bioregional frameworks, or said another way, we look at how the land gives rise to life, and we just do that. We just do that. And we put ourselves inside of it. And so you can imagine this as a mycelial web spreading across North America or Turtle Island, or across South America, across the whole planet. And that's the idea that I wanted to share with you, is that for us to know how to organize the regeneration of the planet, to live into that story, we need to understand how life already organizes us, and then just go from there.